Our goal today is to talk about binomial distribution. So what is a binomial distribution? Remember that we introduced different types of variables. A binomial experiment is a probability experiment that satisfies the following conditions. First of all, the experiment has a fixed number of trials where each trial is independent of the other trials. There are only two possible outcomes of the interest for each trial. Each outcome can be satisfied or classified as success or failure. For the success, we denote it by S. For the failure, we denote it by F. The probability of a success is the same for each trial. Next condition, the random variable X counts the number of successful trials. And of course, we have notations because we're going to use our calculator to do the computations. When we are writing symbol N, it is denoted the number of trials in the experiment. P is the probability of success in a single trial. Q is the probability of failure in a single trial, which is denoted as 1 minus P, or Q. X is the random variable, which represents a count of the number of successes in N trials. Remember that for random variable X, which is discrete, it counts the number of successes. We might have 0 success, we might have 1 success, we might have 2 successes, 3 successes, but up to N successful. All right, so the successes counts up until N, and N is also included. What is the formula for binomial probability distribution? In a binomial experiment, the probability of exactly X successes in N trials is denoted by P of X, which is probability formula. It is N factorial divided by N minus X factorial times X factorial P to the X Q to power N minus X. So what is factorial? In math, when you're seeing factorial is a shorthand form to represent multiplications. First of all, by convention, 0 factorial is equal to 1. 1 factorial is equal to 1 as well. So these two numbers, they are the same. This guy is 0 factorial. By convention, it is 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. Very good. So with this information, let us do a little bit of computations. Question says, find a binomial probability. Rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. Well, this is a binomial experiment. There is no doubt there. The values for N, P, and Q, and X can be written this way. N is the number of trials. We have 3 patients. P is the probability of success, which says 90%. 90% can be written as 9 divided by 10, or 90 divided by 100. You can get rid of 0. Q, or the probability of failure, which is 1 minus 90%, is just 10%, or 1 divided by 10. X is the number of successes because it says 2 patients. So X is equal to 2. The probability of exactly 2 successful surgeries is, we need to follow the formula, the probability of X being 2 is n factorial, which is 3 factorial, divided by 3 minus 2 factorial times 2 factorial, p to power x, q to power n minus x. So the probability of 2 is, on the numerator you have 3 factorial, on the denominator you have 3 minus 2 factorial times 2 factorial. P to the x is 9 over 10 to power 2. Q to power n minus x is 1 divided by 10 to power 1. If you do the computation using what you learned before, 1 factorial is 1, so this guy is just 1. 3 factorial is 6, 2 factorial is 2. Punch these numbers into the calculator and you get 3 times 81 divided by 100, 1 divided by 10, which is 3 times 81 over 1,000, or about 24.3%. So the probability of exactly 2 successful surgeries is very small. It's just 24.3%. This is not a good probability. This is a very small probability when it comes to checking the probability of different types of events. Of course, you can use your calculator and do the computation. But for this question, we are using our formula. This formula is built into the calculator itself. Wherever you see x and wherever it says, hey, probability of exactly 2 successful surgeries, 3 successful surgeries, 1 successful surgeries, you can just punch them into the calculator and do the computation. But here, since we have a nice formula for binomial probability distribution, this is our calculation. When you're using your calculator to find the probability that x is equal to k or 2, you're going to use binomial PDF. For binomial CDF, when you see here, it means that you have cumulative probability. When it says at least, at most, more than, less than, you're using binomial CDF. Other than that, you have to use binomial PDF when it says exactly 2. So here you have a keyword, exactly 2. What function I use to calculate binomial probability when I ask for exactly? So when we are using exactly, is it binomial PDF x equals to a? Is it binomial PDF x less than a? Is it binomial PDF x more than a? When you see exactly, it means that it is binomial PDF x is a. Rotator cuff surgery has a 90% chance of success. Now, suppose we want to use our calculator. In using our calculator, we're going to use second, then go to VARS, and then select the binomial PDF to do the computation. The answer that you should be getting is 73%. Okay. Let me show you how to do the computation using your Calculate84. Go to my Calculate84 and show you what to do. So let me share my screen. Perfect. So you're going to click on second here. And then you're going to click on VARS down here. And then here you need to find binomial PDF. So I'm going to go further down and I'm finding binomial PDF. Okay, in binomial PDF, we need to enter the information, as you can see, as n, comma p, comma x. So n is the total number of people who participated in the surgery, which is going to be 3. So hit 3, then we need a comma. So let us use a comma here. The probability of success was 90%. So you're going to put 0.9, 0.9. Then use your comma again here. And then x, it says, hey, exactly 2. All right. What is the x value? X is exactly 2. So hit 2 and then enter. Perfect. So let's see, what do we have? Shouldn't have this here. Let me erase this. Okay, perfect. Now let us hit enter. Okay. As you can see, you have 0.243 or 24.3%. So one more time. This is the question that we are having. Let me show you the question first. This is the question that we are having. The rotator cuff surgery has 90% chance of success. The surgery is performed on 3 patients. So this is your N, 3 patients. The probability of success is 90% and N is 3. You want to know, find the probability of surgery being successful on exactly 3 patients. So for 2 patients, as you saw before, it's 24.3%. What if you have exactly 3 patients? So let us go back here. Very good. You go to second, and then you click on VARs, everyone. And you need to go further down to find your binomial PDF because it is exactly. Binomial PDF is the one that you're looking for. Okay, so now in your binomial PDF, X, P, and N needs to be identified and write them in order. N is the total number of patients, right? 3 patients. So since we have 3 patients, click on 3. You need a comma. Your comma is just right here. What is P? P is the probability of success. Remember, it was 90%. So you have to put point and then 9, and you get 90%. Then use the comma. And then what is X? It says exactly on 3 patients. All of those 3 patients have successful surgeries. So hit 3 and then enter. So as you can see, it is 0.729 or 73%. Let's go back to our screen. So as you can see, you have about 73%. When the question says, hey, type your answer as decimal point AB, you don't have 0 on the left-hand side. So make sure to follow the same format, 0.73. Perfect. So let us go to the next page. Question says, a survey of US adults found that 63%, let me re-record this for you.